Hi, welcome to this week's VTuber game stream. So we'll just be talking through a few updates of the VTuber project, and thank you so much for joining us. Whether you're on YouTube or Discord, it's all feel free to just give me any feedback, and I'll be there to iterate on the project and develop further. And thank you so much, James, for joining. I know it might be quite late wherever you are, so yeah, thank you so much for joining. I'll be playing a short video and then we're going to dive into the VTuber project, so feel free to let me know. If you have any questions, feel free to just jump in or send us anything in the chat. But yeah, let's start. Welcome to VTuber Studio. If you haven't heard of VTuber Studio before, we have created an open source project for you to customize and stream in your very own studio in Unreal Engine. You will find that apart from integrating media inputs and outputs, we've also offered different integrations such as LiveLink, Twitch, and VMC. So follow the rest of this tutorial series to learn how to clone this project, and we'll cover topics such as dependencies, animation blueprints, swapping out your environments using persistent levels, avatar customization and retargeting, as well as full body tracking via OSC and VMC. So as mentioned, this VTuber Studio project is an open source project, and we've been developing this for the past few months, and to really think of ways where you can VTube directly from Unreal. And there are lots of useful toolkits in there. For example, the OWL live streaming toolkit, allowing you to use different capture systems to stream out of Unreal. But apart from that, we've also built two additional things, two main kind of additional functionalities, including the Twitch integration plugin, as well as our kind of VMC full body tracking animation blueprint. So the tracking doesn't really happen in Unreal itself, but you will be using an external application to stream OSC data into Unreal, where we've built a receiver for you to kind of apply those animations data into an animation blueprint for a metahuman. So we'll be walking through some of that today as well. And I've already covered that in the video you've seen earlier, but the main coverage of the studio project includes media input. So we have screen capture, spout input, as well as NDI inputs. We also have different capture systems. So you are able to capture your VTuber character in the viewport, which is the most kind of efficient and least resource heavy. We've also got the CineCam, allowing you to get nice crisp shots with different field of views and apertures. We also have the 360 capture, which allows you to kind of capture your scene in different kind of 360 modes. So we have panoramic views, we have equirectangular, as well as cube map and kind of like spherical projection. So lots of different ways to look at 360 capture. We've also got the streaming and media output functionalities, allowing you to stream directly out of Unreal. And for those of you who have been using OBS for a long time, this must be something that you might be interested in exploring, so that you can kind of jump away from the kind of Unreal, the OBS space a bit, and just focus on your scene. We've also got the full body tracking via LiveLink and VMC. So this is something maybe some of you are interested in with face tracking and post tracking. That's using an external application, either via XR Animator and also LiveLink app, which is built by Unreal. And then finally, we have Twitch integration and interactivity using Twitch chat and events. So you can listen in different Twitch chats on different channels, subscribe to different Twitch events such as cheering, subscriptions, follow, through our custom plugin that our member has very kindly developed for this open source project. So yes, I've just talked a lot about the VTuber Studio project. That's mostly just information for people who are new to the project, but I'm sure some of you have already heard of the project for some time. The easiest way to gain access to the project is to just go on our GitHub repository. In here you will find this release kind of corner. When you click into it, make sure to download here instead of kind of unwrapping the assets and downloading there. So that's my only advice. You only have to kind of unzip the project and then unzip the project, and then I'll walk through some of the steps later. But first of all, you'll also need different dependencies. So with that, you'll need, of course, Unreal. We've been building on 5.2 for some time, so we're not going to upgrade that just yet, but feel free to explore the functionalities in 5.2. We're using Visual Studio so that you can build source code, because there's C++ code in there. There is, you do not need to learn how to kind of like do C++ scripting at all, because all I'm doing is, most of the bulk of the project is in blueprints, so it's easily configurable. And then to allow yourself to kind of test different streaming capabilities, you are also free to use OBS to see if you can receive any spout input from Unreal. Using this plugin, you'll be able to get spout to receive kind of spout feeds from Unreal. We've also got NDI tools if you want to explore that a little more. And finally, we have the XR animator. So we're going to be focusing primarily on that today. So how to use the VTuber Studio. If you're new to the project, something that I probably don't stress enough is the fact that you'll need to, when you first download the zip file and unzip the project, you can't just immediately click on the U project. It won't open that way, and that's because you'll first have to generate Visual Studio project files. So to do that, you only have to right-click on the project. So I'm going to show you very, very quickly. Just going to share my screen. So to do that, you simply have to right-click on VTuber Studio U project, and then show more options if you're on Windows 11, and click on Generate Visual Studio Project Files. In here, once it clicks, you'll see that the solution file has been generated, so vtuberstudio.sln. When you double-click on this, you'll find Visual Studio is open. And then just follow the kind of steps here by right-clicking on the hierarchy of the project and to build solution. And once that's done, you'll see that the build is successful, and then you can double click on VTuber Studio U project. So how that's done is basically going on the solution VTuber Studio, right click, and you'll find build solution. The other tip is that you'll always have to have Unreal Engine completely closed to be able to build solution, otherwise it will not build. So that's my only tip. And then I'm pretty sure it will just open very smoothly for everyone. So do let me know if you come across any issues, but it should just be build solution, and then you can double click and open up the project. Without further ado, we before looking at the XR animator, I just really wanted to show you the new kind of camera angles that Hardcore Rick has created for us. It's so cool to have those level sequences already programmed in, and so I'm just going to hit play to show you the newest updates. And so this is the kind of where the project is right now. And I'm going to choose Cinecam for these angles, and I'm gonna just choose Cinecam and get out of the kind of UI space. So I'm gonna press. There are some new keys that you can press, including so these are camera angles. Number 1, I need to just change up the aperture and focus. Different angles. We've also got a really nice crisp close-up shot of your character. And then really nice kind of subtle zooming out of the characters to see what they're doing. And then this is a really cool shot as well, also zooming out. And finally, we've got number 5, which is a kind of top-down view, peripheral view of the scene. Yeah, it's so good because I'm really bad at cinematography, so I've tasked Hardcore Rick to help me develop these, and it's looking so much better. So thank you so much for that. So apart from that, we can get on the kind of VTuber side of things, and the first thing you need to set up is motion capture. And so in the scene, we've already kind of configured the project for VMC. I'm just going to quit play and we'll go from here. Been using VMC receiver to take in any kind of streaming feeds. So I'm just going to click and open up XR Animator. And for those of you who don't know what XR Animator is, super quickly, I'm just going to go on GitHub to show you. So we've been using System Animator Online, which is an XR animator built by an indie developer, Butts Young. And to download this, we can basically just go into Releases and click on the Windows zip file, unzip it, and click on the Electron application. So I'm just going to quickly move my XR animator up. And once it starts loading, you should be able to see that there is a character there, and then we have some buttons. The quickest way to configure it is to just double-click streamer mode. And it will start tracking my face and doing everything. And I'm currently using the MediaPipe full body mocap, so while it's calibrating my face data, I'm just gonna not move my mouth. Great, so that's all done. I'm gonna finish and hide everything. And now you should only see this little thumbnail of my face. Now that it's working, we can click on server listen. We can change up. So one thing we need to do is make sure that instead of using animation asset, we're using animation blueprint, and we're using the MetaHuman VMC animation blueprint. This is a custom blueprint I've made, and for face as well, also using the face VMC animation blueprint. And I'm going to click on VMC receiver and server listen. So hopefully it's not too slow at the moment, but you should see that. Just going to slide away from my chair to show you the kind of full body tracking. It's a bit dark where I am, so I might light up my face and everything. You should see all the fingers. Okay, yeah, my fingers are here. And everything is working. So that's the quickest way to really configure your project, is to open the project, download XR Animator, and then make sure that in XR Animator your webcam's all set up. And once that's done, check on the MetaHuman to make sure that the correct animation blueprint for the body as well as face is used. One thing that you can also try doing is swapping out the face animation blueprint with the original one. So you can use LiveLink for the face, which is a much more high fidelity mocap alternative. or is the original solution, and then use your webcam for VMC body tracking for your body. So that's how I would probably use the project to get the kind of highest quality kind of motion capture. I guess I just need to move a bit further away to test this. And I think the legs should also work as well if I move my camera both. So it's constantly, so after maybe a few weeks of using the VMC animation blueprint, I can show you very quickly how this has been tidied up over the past few weeks. So if you first gain access to the project probably like 2 months ago, then you would see that the blueprint was super unreadable and hard to follow. But I've gone to then kind of clean up the blueprint a little and make sure everything's commented. The event graph is slightly irrelevant. It's basically, what I've done here is to get OSC data and then add them to different variables. So we've created a bone data map and a curve map so that they can be used as information for your animation graph. So in the anim graph now, it looks quite scary, but it's actually super intuitive. So when you click into it, you'll see just a lot of lines, everything's tied together, but you don't really have to understand it. You just have to know that this area is for the left hand, and then we have the left arm, and so lower arm, upper arm, and shoulder, and then we're feeding information. We're setting rotations for the right hand and the right arm, so the right arm, and then going to the left leg, right leg, and then finally to the spine and hips. The only trick here again is to stream rotations from the ends of the body to the middle of the body. So that's the only trick I've learned from kind of motion capture retargeting data, which is that because the only information we're using is rotation, we need to make sure that it rotates the right way. Otherwise, the elbow can bend the wrong way and it would look very scary. So the only thing to really go for is to make sure you're bending the fingers first before bending the hand or elbow. So that's how kind of inverse kinematics work in animation, as well as in kind of like skeletal hierarchy. So once that's done, that's already then configured for you. You're free to take this blueprint however you want. So some of you might even choose to kind of glitch the kind of body tracking data and map data from fingers to your legs. That can all be done. And looking at the face blueprint, I feel like I don't talk about the face blueprint enough, which is also a really interesting blueprint, which we've gotten. So we've created a curve map from OSC data. My data is configured for ARKit, so I made sure that everything is named according to ARKit, and then I've remapped everything to the metahuman curves, and didn't do any math on this really. But there's also some kind of additional data I've got, which is left eye and right eye. So using the kind of like rotation, using this kind of like rotation data, we can then actually do a lot of eye tracking or eye tracking games as well. So these blueprints, although they are configured for mocap and streaming and VTuber streaming particularly, you're also free to make really interesting games with it. So feel free to use eye tracking data for any collisions, maybe play ping pong or something in Unreal. Hopefully at some point VTuber streams can be that entertaining. But yeah, I think today that's basically all I have to cover, but if you have any questions, please feel free to say back a little and just send me any. Feel free to also do any screen shares and send me any messages if you come across any problems. And yeah, really nice to see you, Chipko, and thank you so much for coming. I think I'll be doing mostly kind of like 6 p.m., 6:30 streams now to cater to different time zones. I know that people are kind of stationed in different places. So yeah, thank you so much for joining. We're hopefully going to cover different topics soon, and we're also hoping to work on some multiplayer stuff in the future. So all of that collision stuff and thinking about instances and streaming data is really up our street. So if you come across any new tutorials and resources, please feel free to share them as well. Yeah, thank you so much, James, for joining. Again, yeah, if you have any questions, feel free to send us anything, or if you have suggestions for the project as well. I'm still currently working on kind of polishing this up and making sure this is ready to go and it's very easy to read. So all types of user feedback are appreciated. Thank you, Chipko. You've always been the most supportive person, so it makes me feel really good about having worked on this open source project for a while. Yeah, it's only been a few months, but we're ready to make sure this is clean and tidy and ready to go. And yeah, I guess it also is down to computer specs because I'm running on 3080 Ti, and obviously it's smooth enough for me, but I know it won't be smooth for everyone. In terms of documentation for retargeting, so like retargeting data for metahumans, you mean? So what I'm actually doing here is slightly hacky. This VMC data was supposedly used for VRM characters, which are these really cute anime characters. So I've used the animation system, but I'm only really getting the rotation information and streaming that. So there will be documentation on retargeting this, but I think most of the information is housed around these 2 animation blueprints. This is probably the biggest bulk of the work. So that might be what you're looking at. Perfect. Show how I can get microphone input from my PC to control a blueprint at runtime. Yes, absolutely. So if you have followed the project a bit, I'm trying to see if this works on Simulate. Yes. So I'm going to stop VMC because it's killing my performance a little. Nice. So the only thing that's really working, that is really audio responsive is this little pink sphere over here. Again, couldn't have done this without community contributions, and this blueprint was originally built by Sax Electro, amazing Unreal audio person. So in this blueprint, you can also feel free to just clone this and take it however you want. And once you open this blueprint up, the only thing we've done is added in an audio capture component and also attach kind of like sound and submixes to it. So we've separated the submixes so that the input will be muted when it's on the speakers. I don't know if that makes sense. So yeah, it's constantly taking in audio input, but It's not heard by you, but it's streamed out. So that's the kind of audio blueprint we have set up. But to respond to your audio visualization question, the thing that Saks Electro has done is use the on audio envelope value. So using the value and to log it and to clamp the range. So let's say the range of so the range of the value is in a certain range, and to clamp it to 0 to 1. So that's always limited from 0 to 1. And then using that data, you can then remap it to different scales of the sphere, for example, or you can also set scalar parameter value by info. This is usually to do with instances. So let's say like material instances. So for example, if you have a saturation or hue kind of slider or parameter, then you can use this and set this as the intensity of the color, for example. So I think using, okay, and then another thing to look at is also to use, so get the envelope value and then go into, so you can also clamp the range, and then on event tick set certain scales to so you can set the scale of the sphere by the z-axis, which is what we've seen earlier. How would you select? So currently we are using the system default microphone, I think. Haven't actually thought about this, but yeah, I think in terms of capture, we're purely just using the system default. And I wonder if that's something you can search up in project settings or anything. But yeah, currently it's system default, so whatever I have on Windows is whatever I have on the Unreal projects as well. Using a Kinect camera for motion capture versus Electron. So what's usually used for Kinect, from my kind of previous knowledge, I don't really have one and haven't really used any before. Using Kinect, you're trying to access the depth data of the camera, but for webcam, it's much more lightweight. So Electron, what the Electron app does is actually wrapping MediaPipe. So MediaPipe is this Google developed model for it's like a machine learning motion capture library. So this is MediaPipe. It's using single image or like webcam information to track. So it doesn't even require depth data, and all of that depth data is estimated. So it's kind of guessed by machine learning, as opposed to having a lot of information already in the video or video stream. So Kinect probably has a lot more dimensions of data, and MediaPipe relies on just video input. So for example, if you have so that's the kind of main difference. In Kinect, you can access kind of different types of image data as well. So really depends on what you want, but I'm not sure, you might be able to even use Kinect directly in Unreal to get different information. I'm trying to think of what's the best use. I've seen a lot of kind of like Kinect and Touch Designer projects where you get volumetric data, but it would be kind of streaming your actual video scene in the kind of like volumetric data, as opposed to streaming just positions. What we're really doing in this Unreal project is just estimating rotations and positions of the body and then mapping that onto a MetaHuman. So the only thing I'm really changing for the MetaHuman is getting rotation. So the information we need is actually super simple. They're all vector 3. So there are rotations, and if we unfold the rotations, it's all X, Y, Z of pitch, yaw, and roll, and then we're only mapping those back on the joints of the body. So from estimating the joints of the webcam texture human body to the metahuman joints rotation. So that's the kind of, it's the most simple, it's a very simple pose tracking tool. But yeah, I think Kinect camera itself has a lot more information than just a regular webcam camera. I'm also using nothing fancy. It's just a laptop camera that we're using. And we were thinking that maybe in the future we can make a Raspberry Pi camera and then just see if MediaPipe works well. MediaPipe's a bit heavy on the computer, so maybe not, but whether something like that, we can just stream webcam data to maybe a higher spec computer and making sure that that works. But yeah, I think it's something to explore. Again, this is our first iteration. We've literally just figured this out not too long ago. And hopefully we'll be able to use this for more interesting things. So yeah, I guess I can go back to the kind of BP recording, but yeah, if you would like to look at the audio blueprint, I believe I've placed it in here. Let me see. Should be in VTS, VTuber Studio Audio. Yeah. Those are where the blueprints are. Oh, thank you. Not talented at all. It's mostly just consulting a lot of people. There are so many, so including this blueprint, this was built by Sax Electro, and then some camera stuff we've seen today was done by Hardcore Rick, and then we've also had Wesley help us build the Twitch plugin, as well as some of the widget that you've seen, the logic around the widget, all of that. So it's community efforts, group efforts. But feel free, so if you have anything to offer in the future, please feel free to send over what you want kind of developed or what you're interested in developing. And then if you're already comfortable with using GitHub, feel free to send us any kind of pull requests or commit to the project. Amazing. But yeah, thank you so much. I'm just going to hang around here for a bit more time, but yes, feel free to let me know how you get on with cloning the project. And then if you have any questions, feel free to come back every week. I'll just be here streaming, hopefully around this time. I think the turnout is a bit better. We don't have to like squeeze out of work time to join, so that's great. Thank you so much for joining.